Now we're going to look at empirical formula. You have done empirical formula before, grade 10s. We've just done it using the valencies before. So you've worked it up before, so I'd give you a compound and I would say to you, what is the formula for sodium chloride? Okay? And then you would go ahead and you would go, well, sodium is +1, chlorine is -1. You would do your cross multiplication and you would get NaCl. You've done that, okay? However, that's not always, okay, let's just clear this because that's not what I wanted to do. Let's do that. Okay. So, that's not always the it is the easiest way, but it's not always the way we're going to do it because when scientists get a sample of something, they don't know what it necessarily is, so they do some investigation, they do some experiments on it, and then they work out from there what the substance is. So, the empirical formula of a compound shows the simplest ratio in which the elements bond with each other. Simplest ratio. Okay, so let's look at some examples. Now here, what's going to happen is, basically what happens is the scientist gets a substance, the substance gets analyzed, and then they go, in that substance, there's so much oxygen, so much nitrogen, so much whatever, and then they can work out the formula. So, we want to determine the empirical formula for each of the following compounds. What we're going to do here, okay, I just want to get a different color pen because I want you to see what I'm doing. Okay, so first of all, we have 82.4% nitrogen, 17.6% hydrogen. We need to work with the mass. The easiest way to do that is to assume a 100-gram sample. The reason why we assume 100 grams is because then these percentages can just be changed into grams. That makes it easier. We want the simplest ratio, and we're going to do it with a mole ratio. So, knowing the percentages, we have 82.4 grams nitrogen and 17.6 grams hydrogen. We're going to now take each of those, the nitrogen and the hydrogen, and we're going to convert them into moles. So I know it's going to be 82.4 over 14. It's nitrogen atoms. Okay, they're nitrogen atoms, not nitrogen gas. Okay, so it's N, not N2. 5.88 moles. All right, we're going to do the same for the hydrogen, also not H2. So it's 17.6 over 1. So it's 17.6 moles. Now we want the ratio. We want to know how many moles of each we've got to each other. So if we look at the ratio, we've got nitrogen to hydrogen. All right. Nitrogen's 5.88 to 17.6. But you know that we can't have part of a molecule. Okay. We have to have a whole, well, not a molecule, an atom. We have to have a whole atom. So we're going to get this into a whole number. So we divide by the smallest number. Now in this case it's 5.88. When you do the division, I think this is 2.99 over here for the hydrogen. So then we round up to or we round down, whichever the case may be, but we round up to a whole number. Okay, so this tells me that in this substance, for every 1 nitrogen, I have 3 hydrogens. So it's NH3. All right, let's do another one. 83% potassium, 17% oxygen. First step, assume a 100-gram sample. That means that we have 83 grams of potassium, 17 grams of oxygen. We then work out the moles of each of them. So for potassium, it's 83 divided by 39, 2.13. For oxygen, it's going to be 17 divided by 6, 1.06. Hopefully you guys can see already from looking at this what the mole ratio will be. But we've got K to O, potassium to oxygen, 2.13 to 1.06. We're going to divide by the smallest value, which is the 1.06. So that means it gives me a 2-to-1 ratio. K to O. Guys, if you need to stop the video to write this down, then that's what you need to do, or to think through this before you move on. Let's do another one. 32.4% sodium, 22.5% sulfur, 45.1% oxygen. Okay, so assume a 100-gram sample. 32.4 grams sodium, 22.5 grams of sulfur, 41.5 grams of oxygen. We have 3. It doesn't matter. We could have 4. We could have 7. It doesn't actually matter how many we've got. We're going to find the number of moles of sodium, 32.4 divided by 23, then 1.41 moles. Number of moles of sulfur, 22.5 divided by 32, 0.70. Number of moles of oxygen, 45.1 divided by 16, 2.81. Okay? It doesn't matter that these are decimals. It doesn't matter, okay, that this is quite a small decimal, because we'll get them into a whole number. All right? How do we get them into a whole number? By dividing by the smallest number. Okay? So, Na, S, and O. So it's 1.41 to 0.70 to 2.81. Divide by 0.70. Okay? We get 2 to 1 to 4. Very, very, very important. Okay? Very, very important. That means we get Na2SO4. Nice and simple. So, you are now going to do activity 3 on page 199. Remember, the answers are on Teams.